The second part of my lecture is about safety procedure at our clean room in IMAN. Safety is a matter of personal responsibility and awareness of hazard. It is not a matter of regulation and rule if it can be assumed that people think carefully about what they are doing. Safety is what those who have it in call is called common sense. So the note below are on procedure to ensure safety to people. However, you'll find that much more rigid control is needed to ensure the safety of the silicon sample or other sample being made and of the equipment. So most of the equipment requires a great deal of precision and adjustment. So the golden rule is therefore, do not touch anything you are not currently using or with which you are not familiar. If in doubt, ask for help and do not work alone on anything hazardous. On the first day in the clean room, find out about the emergency exit. So any apparatus that appear not to be functioning correctly must be reported to the laboratory management without delay. So this just to show you the layout of our clean room and other laboratories on the same floor in the engineering building. So this slide just to show you, to share with you our first experience in building the clean room in 1994. So this is the piping system with the very simple system, the furnace, the RO water, and also the gas. I think the gas system is already there since 1994. So you can see the chimney or the piping or the cross section of the lab, even though this is not what we have at the moment, but little bit still have relevant. For example, the gas system and also the piping for you to understand how clean rooms was built. So this is the piping system for the PECVD and RIE and gas from the gas room. So you can see the piping is still the same. We have PECVD and we have all the gases, xylene, phosphine, diborane, phosphine, ammonia, nitrous oxide, nitrogen, oxygen, and everything, all the gases as stated in the slide. So how we connect to the machine inside the clean room, so that is the schematic to show you with the valve, everything, for you to understand that it's not direct connection from the gas bottle to the machine. So we have a safety procedure that we have to follow. Okay, this is example of toxic gas panel. You can see we have two parts. The left part is for purging the nitrogen, and the right part is the piping for processed gas. For this case, is xylene, because we know xylene is very toxic. So we need a very sophisticated configuration here. You can so that the gas flow is controlled, and after finish the process, we need to push the line with nitrogen. So you can see the silane line. We have a valve there. When we open the bottle and the gas will flow, and then you can see the pressure of the gas inside the bottle. Then we have a valve. We open the valve and the gas flow, and we have a filter on top. And then we have regulator. Regulator is used to regulate the flow of gas. For example, let's say 10 psi, everything. So now we already set the gas flow to 10 psi or 20 psi, or depend on the what you want. And then we have another valve on top. So that valve is controlled by pneumatic control. So you just press the button inside, and the valve is open and the gas will flow. But on top of the valve, we have overflow sensor. So if the gas flows suddenly, the sudden flow sensor, the sensor will stop, will close, and the gas will block. Then we need to open again, and then so that the gas will flow slowly, not sudden. So and then the gas will flow to the CVD chamber, and then we can do the process. Okay, after finish the process, then we need to shut off the valve, shut off the bottle here outside the clean room, because this is in the gas room. So we close the bottle, gas bottle, and then we let them the gas in the piping to flow to the CVD, or we can push to nitrogen on the left. So we open the valve, and the nitrogen gas will flow, and then push the line. So push all the silent gases, the residues of silent gases. So as you can see, we have a check valve. The check valve is to control so that nitrogen only flow in one direction. Saline cannot flow in that direction. Saline will only flow to the CBD line, not to the purging line or venting line. So that's why we need a check valve, like a diode, flow in one direction only. So we can push the line, and gas will flow through the line, but the CBD is still on the chamber. And when finished, all the gas we vacuum the CBD chamber, and then the tube will fill with nitrogen, not with saline anymore. So when everything okay, we close all the valve, nitrogen valve also, the nitrogen bottle, and that's all. Sometimes we need to vent nitrogen. We can open the vent valve. You can see the gas flow, nitrogen flow. So that is example of gas panel for toxic gases. There are many configuration that we can use, but this is the simple one for our lab. But for the factory, maybe they have very complicated system compared to what we have this one. Okay. Okay, this is the slide just show the DI water system that already explained in detail in our clean room lecture. So I'm not going to explain in detail. So just to show you what we have with the water system in our clean room. Laboratory personnel and chemical safety. So no contact lenses are to be worn inside the clean room or inside the lab. And you have to know the location of eye wash, fire extinguisher, shower station in the laboratory. It is strongly recommended that there are always be 2 qualified students in the laboratory at all times. So there should be no laser reading inside the laboratory. Laser talking is permitted, however, only necessary talking is to be occur during chemical processing. So chemical safety glasses should be worn at all times during chemical processing. So all chemical must be poured at a working fume hood or wet station. Do not pour chemical if exhaust is inadequate. So you must always check the exhaust, whether the exhaust is on or off, or is adequate enough to suck the gas or the chemical vapor. Chemical resistant glove and face shield must be worn when pouring chemical, and apron should also be worn. Only approved chemical, those already listed in the guidebook, and may be used in the lab. So no other chemical is allowed to bring in the lab. So new chemical, those not already in the lab, must be approved by the lab management. So this is very important to avoid contamination. So chemical handling rule. So all warning and procedures regarding storage and disposal, etc., must be followed. So chemical poured in open beaker must remain under the fume hood and do not move them out of the fume hood. And do not heat highly flammable liquids such as acetone, methanol, ethanol, and any other solvent. Turn off hot plate when finished. And all chemical must be stored in a clear marked, sealed container of a material compatible with the chemical. For example, do not use glass for HF. You must always use Pyrex or glass. And marking must include, so marking on the beaker must include a chemical name, professors or lecturer, or your supervisor, and date of chemical was brought into the lab, and for what application. So you can mark the beaker, because uh, you are not only a student working in the lab, other students also working in the lab, and they also want to use the chemical, and so to avoid to mix with other chemical or your friend's chemical, so you must mark clearly on the beaker or bottle. And do not remove or dispose hot chemical, let them cool first. And chemical must be stored in appropriate cabinet except when in actual use. For example, acid must be stored in the acid cabinet, base is in base cabinet, solvent in the solvent cabinet. Don't mix them. So waste chemical must be stored in chemical waste cabinet in clearly marked container, and do not overfill. Chemical must not be stored or left for appropriate amount of time, or the floor, on the on the floor or table. It must be labeled as the chemical name and or the strength of the mixture. So what chemical, what name, or you mix, dilute the chemical. For example, you must state the strength of the chemical, the percentage, for example, 10% or 20% HF, for example. Chemical must not be stored underneath fume hood. So this is very, very important, especially for students who want to continue the experiment in the afternoon. So they put the chemical underneath fume hood so that they can continue later. So this is not the correct way, and please avoid to do that. Strongly fumed chemicals such as hydrochloric acid and ammonium hydroxide must be used only in the recessed hot pot area in the fume hood. So if strong odor are present during chemical processing, so please stop and turn off hot plate, call lab management and evacuate at the area. Do not continue processing if you smell fume. So this is the rule. If you smell something in the clean room, so the clean room is not clean, slowly contaminated. So it is recommended that you have your own personal chemical resistant glove. You must have your own, and wash glove in the eye water after use. Very important to rinse or wash your glove after use, after you finish your experiment. So triple rinse empty chemical bottle, including cap and a fixed rinse label. Date and initial it, and place rinse bottle back in the appropriate cabinet if there is a room, or on the floor near cabinet, out of the way if there is no room. Chemical waste must be poured Add the fume hood into the appropriate label waste bottle. Wipe down outside of waste bottle with the eye water and clean wipe. If chemical processing at fume hood needs to continue in your absence, you must label it with your name, chemical use, time and date of pour, your phone number, and when you will finish. Report all spill or chemical exposure to lab management. Use appropriate fume hood, example, solvent hood for solvent, acid hood for acid, and base for base. Report unsafe condition or safety violation by others to lab management. Liquid chemical safety, solvent. So all solvents are hazardous to some degree. In particular, trichloroethylene or TCA is rapidly absorbed through the skin and can cause cumulative liver or kidney damage. So always minimize personal exposure to solvent in any form. Always use a ventilated hood. Using absorbent wipes and towel can collect the spill solvent. Treat all towel and hazardous waste after cleanup. So we treat all towel as hazardous waste after cleanup. So hydrofluoric acid, HF. Beware of contact in all form. HF is a weak acid, and you may not even feel if you get some on your skin. But fluorine can diffuse rapidly to your bone and can severe damage. So if contact occur, wash it once copiously in running water for a minimum of 15 minutes. Always use under ventilated hood. No matter how diluted can be HF acid can be neutralized if spilled by lime or natural acid spray neutralizer or HF neutralizer gel in toothpaste type tube. HF or hydrofluoric acid should be treated with extremely caution. Although far more powerful than most strong acid, it may not cause immediate reaction on skin contact with it. So wash it off with the skin with copious amount of water and follow the following first aid instruction immediately. So failure to do so could lead to lasting effect. Burn. Thoroughly wash the affected area with sodium bicarbonate and rub the magnesia ointment and apply a dressing. So for eye injuries, flood the eye with sodium bicarbonate solution and repeat washing for 1 hour. So for both, the patient must be examined by doctor as soon as possible. But before you take the patient to doctor, you must do this. So neutralize all equipment with sodium bicarbonate. So sodium bicarbonate is very important. You can use to neutralize for the equipment as well. So hydrogen peroxide. Hydrogen peroxide will bleach and oxidize skin. So be careful. So take particular care with mixing the acid. So nitric acid, concentrated and fume grade are used for different purposes and they should not be confused. So ammonium fluoride, which is often mixed with HF, will itself cause skin damage. So these all chemical or liquid chemical are very dangerous, and we have. So use all chemical at appropriate vented chemical hood. So when using a vented chemical hood, always confirm that the exhaust system is operational. So always wear chemical glove. So if PVC glove are used, double glove each hand for extra safety. Do not use PVC glove for protection from acetone. Recommended use yellow or green nylon or rubber or nitrile glove for chemical work. So when working with chemical, always wear goggle and face shield to protect clothes, a lab apron is required for chemical work by students. So always close chemical cabinet door after removing or replacing chemical. So always attempt to keep talking to a minimum and restrict conversation to what is related to laboratory environment only. So all chemicals should be disposed of into appropriate specified waste container. If a specific waste container is not available for that chemical in use, contact lab management. So never leave chemical unattended, even with notice, for over 8 hours. Silicon, aluminum, quartzware, and other laboratory supplies or materials should handle only with glove or tweezers. So never use bare hand. No? A good rule of thumb is that if the silicon wafer or devices come in contact with a surface you are touching, so always have a clean glove. So whenever a wafer touches a dirty surface, it should be assumed that the wafer is now contaminated and must be re-cleaned. So gas safety. So gas cylinder should be only changed by a laboratory technician. So student is not allowed to change or to open and close the valve of gases in the gas room. The LPCVD or PECVD or RE reactors and the special gases must only be used with permission from authorized personnel. The lab manager, or for this case last time, because I am the, the lab manager and lab leader, so permission from me is very important. But now the manager may be other people, so you must get a permission from the manager first. Other hazard. First is liquid nitrogen. So use glove and eye protection when pouring liquid nitrogen. So avoid spilling large quantity because the nitrogen gas can displace the air in a confined space such as the clean room. So the percentage of oxygen become less compared to nitrogen and you have difficult to breathe. So vacuum system, open valve slowly in case of malfunction. Admit nitrogen carefully when bringing the system up to atmosphere pressure, or the bell jar may be blown off. Compressed air or high pressure nitrogen. So never use compressed air for cleaning, clothing, or any part of body. So this practice is very dangerous, especially around the mouth, eyes, ears, and etc. So never indulge in a so-called practical joke with compressed air. Remember, an air hose can wipe around if not held securely. So high voltage used in the vacuum system are enclosed and do not unplug anything while it is running. So some waste disposal procedure. So only the following commonly used acid may be poured or aspirated down the drain with extreme dilution. There is sulfuric acid, phosphoric acid, nitric acid, and hydrochloric acid. No other chemical are to be disposed down the drain in the lab without the authorization of lab management. Hydrofluoric acid must not be disposed of down the drain, regardless of the concentration. So always use a waste container for disposing HF acid. Chemical containers. So we have two types of chemical container. One is non-empty, one is empty. For non-empty, do not pour a chemical down the drain. Instead, label the chemical, bottle or container with hazardous substance identification tag. Set the chemical or chemical waste in the appropriate chemical storage or cabinet, such as acid, base, or flammable. For empty, water rinse container 3 times with water. Right, rinse or the bottle or container and put it into the section of appropriate chemical cabinet. So note, all bottle, whenever rinsed or not, that are not tagged with hazardous substance identification tag must be rinsed by the lab staff. So please rinse your bottle and write rinse on it. You just level rinse on the bottle so that people know the bottle is already rinsed. So important telephone numbers. So all users, operators, students must know the telephone number of very important person or office to contact. For example, ambulance or fire brigade, and also the manager of the lab. So for this case, it's still you can see the name is listed, but the new one maybe we can replace it with new contact number. So all students or operators, before they can work in the clean room, they must attend the lecture of safety. And after take some simple tests, so we can issue a letter of certificate so that they can to show that they are clean room users. And the name is appear, and also the supervisor name, and also the lab manager. Yeah, I think that's all, and thank you for follow the lecture, which is very important for clean room user. So before you is allowed to enter and working in the clean room, you must understand the safety and very minimum condition. You must attend this lecture and take some test, a simple test, to show that you understand about the safety in the working in the clean room. So I think that's all. Thank you very much.